Welcome back, everybody. In this video, I'm talking about something that I really enjoy, which, believe it or not, is error messages. And that's because I think that useful error messages are one of the most underrated things when you're really architecting your code. Because sure, you don't want things to throw errors, but what's worse is a useless error. Because if errors have to occur, which they will eventually, it's best to know why, how, and where that error occurred. And I'm going to show you in this video, following up on my previous video about handling errors with promises in multiple locations, to show you how you can take advantage of different lexical environments to give super useful error messages using promises. So first, what you're looking at here is the database that we're going to be using for this example code that I wrote. So it's just obviously a JSON file, nothing super involved, and what I've created around this so-called database is really just a somewhat functioning API that allows you to produce, or allows you to post and get. And what it actually does under the covers is accept a post request, which will then process the data in this based on your generate a table, so a two-dimensional array, and then send you the location so that you can get location. It's currently just running on my local server, and let's get started with it. So we're going to start by looking at some of the errors I've already provided in the server. And we'll do that by first executing some of the code that we have set up here so that we can see some errors that are generated, and then we'll look at how they're implemented. So I have a payload. This is payload 1. We'll eventually get around to using a second payload. So I guess to avoid distraction, let's comment that guy out. There we go. So we're looking at payload 1 and post config 1. So payload 1, we're going to request one grouping. I was going to do multiple groupings, but it only ended up working that you could use one, and I realized I was getting a bit out of hand with setting up this video anyway. But you can pass in one grouping and then the columns that you want. So if we go back to our database, what this will give us is a summary of this data based on the club. So we'll have everything for the blue club and everything for the green club, and then we will choose the columns of score and rep so that we add the scores together and we add the reps together. So if we execute that, well, let's go back to this, to where we're actually executing it. We just have this little main here where we are going to post the report, then we'll get the report, and then we'll just console log it. So let's see if this guy runs. As you can see, I already have some stuff here. I always forget to clear my console. Oops. Let's clear that. And we'll just run it again. And so what we get is club blue with the totals for score and rep, and green with the total for score and rep. Now, what happens if, for example, we don't pass in a grouping? So we send in an empty grouping array. Then we get back the API returned an error, must provide a grouping. That's useful. We know exactly what we did wrong. Likewise, if we spell one of the columns wrong, then we get the API returned an error. Cannot generate report with provided input. The error, that column does not exist. Super useful. We know what went on. So that's examples of a couple of things, how the API works. Hopefully you have a general understanding of what I built out and what we'll be working with here. But let's actually dive in now to what the error handling looks like. So it's just an Express server, and this is not production ready code that I've picked through and made sure it's really pretty. It's quite ugly, but it will work for our example. So here we have our server, and it'll accept any post request to reports. And the first thing that we check is if the request comes with a groupings that has a length of 0. So what does that mean? It means that they did not provide a grouping. And at this initial checkpoint, that's all we really know. We just can check whether they did or did not Digger did not provide a grouping. If they didn't provide a grouping, then it'll have a length of 0, and we say you must provide a grouping. We don't care about whether anything else is wrong with the message or with the request object because we need a grouping. Likewise, we can do the same thing with columns. If there are no elements in the columns array, then we can let them know, hey, you must provide one or more columns. We can't do anything with that. So those are a couple general catch-all errors that we can use based on columns and groupings. Now, obviously, these are very general. If, for example, they passed me an object as the groupings, I'm not catching anything there. But this is just to show you ways you can think about throwing errors. Now, the reason why this is a general error is because we haven't dived into the code base yet, into the database yet, but we're going to do that in a minute. So if this passes, if we get past all these potential errors in the formatting of the request object, then we are going to create an ID, which this is, we're just going to count how many reports we've generated so far, and then we'll just pass that in so that we can increment by 1. It's not a great way to generate an ID, but it totally works, at least for my local example here. And then we just pass that into generate report, which will give us back a promise. So let's check out generate report. We're passing in the groupings, the columns, and the ID. So if we look at generate report, I've hidden a couple things just that were particularly ugly and distracting. But if we take a general look at it, it's returning get file content, which gives us a promise. Excellent. So we're returning a promise. And then we can just look at all the data in the database. So we'll parse that data because it's going to be returned as a string. And then we can map over groupings. Our message that we got back is going to be specific to the grouping and to the user that throws the error. So in this case, we are going to map over every grouping. And for each grouping that was provided, because again, it only accepts one grouping currently, but hypothetically it could accept many, we're going to have the specific grouping that's causing the problem. You know what user is causing the problem. So if we look at a situation in our code or a lexical environment in our code where we have access to the specific grouping and the specific user, then we can return a useful error message based on that information. And that's what we're throwing here. Grouping does not exist on user, and then the index. So let's go back to our code, run.js, and take a look at what would happen if we spelt club wrong. So let's go up here, let's remove that. The API returned an error. Cannot generate report with provided input. Error group CLB does not exist on user 0. What does that really mean? What that means is that we sent in a grouping that does not exist on a particular user. So right now we know that club without a U does not exist anywhere in our database. That's not a grouping that we can actually search for. But potentially we passing a correct club, CLUB. And then there was an error in the database where it was spelled without a U, for example. We would want to know which user caused that error. It wouldn't just be the first one, it would be that particular user, maybe user 200. But we would get that specific message back because we've sent that error in that particular lexical environment. And so that's going to be a lot better than just having something like, hey, we didn't find your data, or unprocessable entity. That's always great, right? There are more useful things that you can set up, and we're starting with the backend code, but we'll get to the client side, that will give you more information when you need to debug your code. So let's oops. That's then server.js. All right. Here's some helper functions. So let's do the same thing then for columns, because currently we're just returning that general statement of column does not exist, but we haven't told them what column, and we haven't told them what user we're working on. And if we look at our environment, we can see that we are inside of a particular situation that's looking at one user, and we are looking at a particular column. So we can provide that data to the developer out of our API. And we can do that just with column, if we spell it right. Or actually do it the exact same format, column, does not exist on user, close your brackets there, or there we go, on I. Obviously with this extra large text, it's getting hard to read. I will just push that back, don't kill me. And now we've taken advantage of our lexical environment to give a super specific message. Obviously, we just copied the same code or the same expression that we used for grouping, but it's going to be really useful to our user or whoever is developing this code, because it'll be easy to look at and say, all right, we have a particular issue, we have an issue with a particular column and a particular user. It's going to be one of those two things that caused the problem, or both. And so you'll notice that there was more detail in that returned error than just column does not exist on user, and then the user. There was some other data preceding it, things like the API threw an error. And that's because the benefit of promises being monadic is that they remember the context from past calculations. That's the purpose of a monad, which means that if we pass a catch, if we return something from a catch and we throw it so that it gets passed immediately to another catch, we can accept that error, this return value, in another catch. Oops, I'm missing a tilde. And here, there we go. We can accept that in another catch as a variable and then interpolate it each time. So if we go down here, whoa, what is that? Not totally sure. But anyway, we can then catch it down here. And we store that entire expression about column this is not does not exist on user this. And we can wrap it again in cannot generate report with provided input, error, and then that's where our expression from above goes. And so you can see how these turtled down into more and more useful error messages. And so by the time it reaches the end user, they have the opportunity to look at it and see all this extra data that's accumulated, the transformation of their data. So that's server side, right? That's fine. Most APIs are probably just going to send you back a status code, and that'll be fine. And that's really all you get. But if you pass through everything successfully, in this particular API, it's going to send you back a JSON string as the body content with a location property. And it's going to give you the location of that current, of that most recently generated report. And so if we go back to run.js just to check it out, at this point we will then ingest it here. We'll post report, and then we will pass it into get report. So get reports, if there are any errors, we just have some generalized errors. We will get to those in a second. What am I looking for here? I'm looking for, oh, right here. I am looking at the right spot. If we send it to the wrong path, right? So if we just send in a bunch of nonsense, we've set it up on the server side to have some useful error messages on the GET request as well. Spelling everything correctly there. The API returned an error, fetch request to, oh, that's socket hangup, so that's not going to be a useful message that I set up. And we do this one more time, run. Oh, it doesn't like my connection now. Huh? No. All right, it's failing me at the moment. Let me see if I run it successfully, if it'll work. Okay. Oh, there's probably an issue. I probably broke something in my code on my server side. Can't believe in you. This works. There we go. Node Oh, I want to throw that error. Okay. For whatever reason, this isn't working. It was working when I was testing it before. But the point was, it was going to send me back an error that said that you could not find a report at that location. So what does that look like? If I go to the server, what I'll do is wrap that search for that particular location in a promise. And so that's going to be returned to anything that calls this, this function. We used it earlier in post report because we were going to get the file content from the database. And now we need to get the file content from the report file that we generated. And so if they pass in, if the user or the developer passes in a path that does not exist for a particular report, then we can check the error code, see if, however you pronounce this, is the code, which means that the file does not exist. And if so, we can give them a more useful message, which is reject no report at that location. Otherwise, we'll just send the general error message. So I wish this was working. I'm not totally sure whether I broke something while I was updating the other error message, but it was working when I was testing it a few minutes ago. Point is, that's the kind of error that I was trying to send out. Now, what does this mean for your code on the client side? Because maybe you don't do a lot of server-side code. You're dealing with situations like this. So when you want to post something and then you get a response, you have the option of handling it if it's not a 200 to just throw request or response.status text, right? And in this case, it's going to give you useful messages because we've set up the server to give you useful messages. But sometimes it'll just be something like unprocessable entity or invalid request, something like that. And then you want to provide some more context. Now, in this particular situation, we don't have a lot of options because we're not mapping over a whole bunch of requests. So it doesn't really give us a good index or anything like that, but we do have access to the options. And this is how I want you to think when you're trying to set yourself up with useful errors. So you could say returned an error, and then instead of just throwing the error, you could say returned an error on request, and then just pass in that request that you are currently forwarding onto the API. So it might be something like options.body, right? And then period, and then error. Right, so now at least you can look at it and say, okay, well maybe if you had a typo in that particular body, you could look at it and just do a find and replace and just fix it in your own code. So let me see if my my server is going to work properly now. Excuse me. Yes, it is. Let me throw an error. There we go. So the API returned an error on request, and then we can look at the request object that we passed in. Groupings, and we can see, all right, this is a small piece of code to have to look at and find the problem. It's pretty easy to see CLU is not one of the groupings that are available to us. So that's the error. It's easy to spot. And then the actual error is cannot generate report with provided input. So if we didn't see that immediately, we could say, okay, there's something wrong with the input that we provided, and look at that. But because we've already added extra errors on the server side, we also get grouping CLU does not exist on user 0. You have all the information you could possibly need in order to generate or in order to debug this program, because you've provided context at every single step, and it's just been smushed together at every point in the catch chain. So we think a lot about passing data from a then to a then to a then to a then, or more realistically through a then to another promise. But what we don't often seem to think about as much is using catches and passing an error to another catch and providing it with that data in the lexical scope. Because every time we close over a section or a group of variables, we might as well use those for either ourselves or a future developer to have more useful information about why that failure occurred. So in this particular example, we have a bunch of things that all point to this being the problem, the CLU. And then if we fix that, obviously it's going to work just fine. Let's do we could do the same thing with something down here, just a request to, with this options to this path didn't work, but I think you get the point. The point isn't necessarily that this is the most groundbreaking code, it's to get you thinking about how these things can be used in your own code. But that's not my favorite thing about all this, right? My favorite thing about all this, and I guess I don't even really need to use the double. I was going to use that to show you the different objects. So for example, in the options above, I said on this particular request object, but it doesn't really matter. I think I'll just delete that because I don't imagine that it's unclear without having 2 reports running. So let's just remove this. All right, so, but this isn't the most useful thing. Right now, we're just console logging it. Usually, you'll have a bunch of stakeholders involved. So maybe it's the user that pushed a button in the UI. They need to be notified right away if a particular error occurred because they are expecting a response. And if that response isn't going to come, you better let them know. But depending on the type of error, sometimes the developer needs to know. Sometimes the developer doesn't need to know. It was the user's fault. And the developer should not need to be notified every single time that the user provides crappy data. So there's a bunch of different situations here. And this is my favorite way to set up catches. So if you have this global catch, again, if the idea of having a global catch or handling your errors in multiple places is very foreign to you, check out my last video. I'm very happy with how that one turned out. So check that one out. And then get ready for something like this. So we'll grab these little helper functions and this. Let's move this up here. That. And so what we have inside of our catch statement now, or our catch, sorry, is a switch statement. And this has totally changed the way that I'm able to handle different errors in my code. And we do that by wrapping everything in a pair, where we have the error message itself and then some context. I'm calling it a flag. You can call it whatever you want. But you give it that context. And this might change as it passes throughout your program. So maybe you only have it ascending so that it starts out as dev only, or it starts out as user, and then it becomes maybe the default. So you just remove it if it's been, or whatever situations you might have where it accumulates. So it's like this person always needs to know no matter what. Sometimes this person needs to know, and then you have a situation where they both need to know. That might change as the error moves throughout your program. Point is, it allows you to handle things in different ways so that if it's a dev-only issue, you can alert only the dev. If it's the user, you might update the UI. And if it's a log, say this is just happening in the background automated on a server, then you can log an error out to the, maybe if it's a cron job, it'll email you if you're the dev or something. And then just, I have a default setup here where it's going to, if none of these were set, it'll alert the developer that an issue occurred and output to the UI. This is a fictional case, but I think it really shows you how this works. So let's hop back up to the top here and take a look at how we can implement this for our post request. So if we go here, we can now, instead of just throwing a single string, I was pointing at my own screen as if you can see that, string, let's make that our pair, our value and our context pair. And let's say dev only. Now if we run this, assuming that unexpected token case, oh, I think I'm forgetting a curly brace. Yism. Let's run this. Oh, I forgot to actually throw an error. It'll be hard to alert the dev of no error. So let's remove the alerting dev of error. The API returned an error on request. This particular grouping, or this particular request, this error occurred, cannot generate report with providing input. And we're telling the dev about that. So maybe this would email he or she, or this would Slack message them, something like that. Again, maybe instead of this being a dev-specific issue, this is going to be a user issue. And it's as easy as just switching it to a different context. So if we run this, the dev will update the UI. And this perhaps happens to be a totally different failure, but point is, it's going to tell the user. Now, obviously, you would probably need to do this with some more context. It's just not just, hey, if I post a report, I need to tell the user. It would be something like, if it's this particular status code, maybe we alert the dev versus alert the user. Maybe if it fails for a particular reason. So if you know that the server, maybe you're in charge of both, and the server gives really useful error messages or error codes, you could say, sort of like we did on the server side, where we checked error.code equals, and then that code to see that, or to say that the file does not exist. You could do something like that. If this, then return the error in this state, or this message with this context. So I'll just rag it for you, just to show you an example. So it might be something like if error.code equals, and then we'll do that one. I think it's ENT. That's the one from above, or from the server side. So if we had that code, maybe, then maybe we'll alert the dev only. And we'd probably stash this in a variable so we don't have to write it out every time. But for now, I'll just leave it like that, because this is a fictional case anyway. But we could check that. Otherwise, we might do a different situation. So like that. And just do an else if error.code equals yummy. Then we alert the user. Right? This is how I want you to think about your error handling, because I recently had a situation where my team needed to be Slack messaged a bunch of errors. The difference, though, is that I cared about a bunch of errors that weren't relevant to them. And so I needed to set something up where I could be alerted of general errors and specific errors, but they needed to be alerted to a different set of errors. And so this created that perfect situation where we're able to globally catch a whole bunch of errors and output it in a generalized format, which if we go back down to our code, down here, it's just passing in the error, right? That's all we're doing, is we're just passing in the error, because by the time it gets to our generalized catch, the error has been fully formatted. We have all the information we need and ever will have. We don't need to add extra context here. The only context we need to check is the flag of who cares about this error at this point. And so if you've set up your program to provide the right context by the time it reaches your global catch, then you can handle it in all these different ways without having to do anything too crazy. And again, this might be, instead of just a console log, this would be something like emailing that person, or messaging on Slack, or logging the error on the back end. So anyway, I know I got a little carried away with AI. I had a lot of fun with it, which is great. This is why I do these videos, because I really enjoy it, and hopefully it's helping somebody. But too confusing, I really think this is useful, guys. If you're building to consume, or if you're writing code that you're going to have to maintain later, you will thank yourself for writing these super specific messages by using what's available to you in your lexical scope as the error moves throughout your program. And keep in mind the benefit of the fact that promises are monadic is that you can pass this data through the chain. And it's not just if the chain is successful, you can also pass it to other failures. So you can do it. You can wrap things in try catches if you need to, maybe if you don't have a safe value. So if you're trying to map over a value that a user passed in, it might be undefined, or if you have to request to another API, which is the situation I was in, you had to pass to another API and wasn't able to make it into a safe value that you would need to map over later. Sometimes you can't map over undefined, and the program gets mad at you. If you wrap that in a try catch, you can throw a very specific error that tells the developer specifically, because that was a unique, strange failure, tells the developer, hey, users are passing in this kind of data, maybe validate, maybe add some data validation to it. Something like that. It's something that I find really useful. Hopefully you do as well. Hopefully you enjoyed this video and learned something. If you did, leave a comment down below. I'd love to hear about it. Again, don't judge my code too much in this video. It was meant to be functioning and to give you a working code example without me having to pseudocode stuff. But it wasn't meant to be production grade, gold standard code. So I'll see you in the next video. Hope you enjoyed this one. Have a good one, guys.